Okay, for this video, we're going to be talking about rational numbers to decimals. And I want you to get out these notes. This is what it says at the top. And we're kind of going to ignore these first two sections where it says the steps and then guided practice. We'll look at those a little later. For now, I just want to talk about some different types of decimals. So you don't have to write this down unless you want to. If you do, remember you can pause the video if you need some more time. So the first kind of decimal that we're going to talk about is terminating decimals. And terminating, that word you probably recognize like the Terminator. It means that it comes to an end or it ends something. The Terminator ends things. So a terminating decimal has an end. And an example would be like 3.27. 3.27 comes to an end. It's got a decimal point, it's got a couple numbers after it, and then it stops. Another example would be 2.1. That is a decimal that comes to an end, it terminates. And then another example would be like -1. -1 is a whole is an integer, and we don't see a decimal point there, but if we put 0.0, that doesn't change the fact that it's just -1. -1 and -1.0 are the same things. So those are all examples of terminating decimals. Another type of decimal would be the opposite of that, a non-terminating decimal. And that is a decimal that goes on forever and ever. It never stops. So obviously that's not something that I can write down, but if we had something like 3.712653 and it just kept going on and on forever, I'm just going to put ... That's a non-terminating decimal because we can never find the end of it. Another specific type of non-terminating decimals is called a repeating decimal. So that would be like if we had 2.3333 and it just kept going with those threes. That 3 right there repeats. And another way that we can write that is 2.3, and then we put a little bar over the top of the 3. And that tells us that this number is 2.33333 and so on. It keeps on going. So that is called a repeating decimal. And if you've ever heard of the number pi, 3.1415, and it continues forever, that's a non-terminating decimal. It never ends. And that's something that is not repeating because it goes on forever without a pattern. This, a repeating decimal, has a pattern. Okay? So we're going to do some practice with that. And where it says independent practice down here, I want you to try to use your calculator for this. So when we have a decimal, 7 divided by 9, 7 over 9, that fraction actually means division. So this little fraction bar tells us that we're dividing. So the way that we write that is 7, the number that's on top, divided by 9. So the number that's on top always comes first, and it's divided by 9, the number on the bottom. So if you're going to turn this into a decimal on your calculator, just go ahead and turn that on, clear your screen, and let's type in 7 divided by 9 and see what you get. So you get 0.77777 and then an 8. Well, that 8 is the end there. On the end, they're just rounding that up. It actually will keep going with sevens if our calculator extended for miles. So the way that we're going to write that is 0.7 repeating. And that's an example of a non-terminating repeating decimal because it goes on forever, it doesn't terminate, and it's repeating. It has that special pattern with the sevens. Let's try the next one, 3/5. And I'm going to type in 3 divided by 5. That gives me 0.6. So that was 3 divided by 5. 0.6 is a terminating decimal. It stops. Okay, I'm going to skip this one for now and look at this one down here. 1 and 4/15. Now be careful when you type that into your calculator, because if you just type a 1 and then a 4, your calculator is not going to know that that's a mixed number like this. So what you should do is just type in this smaller part, the actual fraction part, 4/15, which is 4 divided by 15. So if I type that in, 4 divided by 15, I get 0.266666667. Well, that 7 again is just rounded, so we actually have a pattern of these 6s. So that is 4 divided by 15 is 0.26 repeating, and only that 6 repeats. So you only have to draw the line over the 6, not the 2. But our original number was 1 and 4/15. So our final answer, we need to include that 1. And that 1 is just added to this. So instead of 0.26 repeating, we're going to have 1.26 repeating. Okay, so go ahead and try these last 3 by yourself. Try those last 3 by yourself. And then that will be the end of this little session.